Open our project. Let's make some changes on the form for better viewing. Yes, let's move timers on the side. In any case, it's invisible when you run the program. Okay, let's move the label which display frequency on this side. Let's create new label. Let's change properties. Font bold. Let's select font Calibri and height 14. And in property caption, let's name it VFOA. So let's make it on the same top 32 for both. And let's make text in the label which display frequency. Let's type all zeros. Let's run it. Okay, what we have now. Okay, let's connect and read. So now we can see the frequency. Let's make it more fancy. In any case, in future we will remove all these fields from the main form, because it's necessary only one time when we connect to the radio. So right now we're using it on the main form just for quick access to the settings. Okay, let's change some properties to looks better. Okay, now it looks better. So let's make a function to read the frequency. So we don't need every time to type all this code when we need to read frequency. I already prepared this function, so let's just copy and paste it, and let me explain you for each field what does it mean. So we create function, let's call it bool. It's mean logic, yes or no, false or true. So and call this function read VFO. Inside this function will be three variables: handle age, integer a, and char b. We can write char b without star in front, but in this case we should write the size of the char, so better we will do it like this. Okay, when we run the frequency, the first we will check if the handle serial port is available. If handle is null, then we return 0. It means false. This function will return false. Let's create char buf. We need this buffer to read the data. Inside this function, let's declare dword bytes read, bytes write. Char read frequency, read f 6 bytes, fe 0 e0 03 fd. Let's put second byte 0 1 2 third byte, but it's called read f2 as radio ID. In our function we named it integer a, so it's a. Then we read file, write file. Let's make integer len, which will be bytes read. And now let's work on the possible errors. If len is less than 7, return false. It means that probably it will be response will be 0 bytes, but if in any case if it's less than 7 bytes, response is incorrect. Let's create integer r1, which will be memory compare buffer and read f char and 6. So we compare 6 bytes. It should be same. If it's same, r1 is equal 0. If r1 not equal 0, we return false. Next error check. If last byte is not equal 0 fd, we also return 0 because it's not CI-V command response or response not complete or incorrect. Okay, let's create char frac 5 bytes in which we will copy the frequency. memcpy 5 bytes from buffer from 11th byte, and let's create 5 integer c5 string vfo, and for integer equals 0 to integer 5, let's copy bytes from and convert to integer bytes from frequency char, and to make a line vfo line with frequency. Then, as we did before, we convert string to integer to remove zeros in the front, and then convert back to string. We already created integer len, so let's use it here. We will do length as length of the VFO string, and let's create integer k, which will be 9 minus len minus VFO string length. 9 is because we thinking maximum length is 9 bytes for VHF frequency, like 432 MHz. And now using k, we can create a string with variable k, so we don't need to make three possibilities like we did before. So we're doing only one. VFO equal VFO dot substring 1 and size 3 minus k plus VFO substring 4 minus k 3, and last VFO substring 7 minus k 3. So let's run it to see if function is doesn't have any errors. Now let's make changes here. Let's remove everything from the button read. We don't need anything here except timer. We will need only timer, enable timer here. But now we don't, before starting timer, let's just check our function. So let's create a variable, logic variable bool OK equal read VFO. Inside is our variables like serial port HCOM. Next integer radio ID, and let's create global variable for the frequency line. Let's call it VFO data. And in global variables, let's declare it as char VFO data. Let's make it 100 bytes size. Okay, let's connect. Okay, here in the button connect, let's make a radio ID as edit to text field, convert it to integer, string to integer, edit to text. Okay, here everything looks correct, so let's write label 5 caption is V for data. Let's make error check. If OK is equal true, then label 1 caption is V for data. Else we will do nothing, so old frequency will be displayed. Okay, let's run it. Port, change baud rate, connect, read. So we can read the frequency read correct. Now let's remove everything from the timer. We don't need it anymore. Let's copy everything from the read button and paste it into the timer. And from button add-in, let's delete everything and only put the timer 1 enabled true. So when we press read button, reading frequency will be in timer every 500 milliseconds, twice a second. Read. Okay, we can read frequency. Let's spin the tuning knob on transceiver. We can see it's working. In the timer, let's change the timer interval. 500 is too much. Let's make 50 milliseconds. So the data will be renewed every 50 milliseconds. Okay, now it looks much better. Okay, when we create in the place where we create the form, let's make our form double buffered. Form 1 double buffered equal true. We need it when the data exchange very fast. If we will not do it, some fields may be flashing. So let's create the same function, read VFO, but we will make it with error check. So we called it integer, because we need for every error we need a different number. And let's go one by one. If a handle is null, we return 0. It means port not available. Next error, if bytes read less than 7, no response from the radio. If first 6 bytes not received not equal to first 6 bytes sent, it's also error that incorrect response. And if last byte is not equal 0 FD, that it's not a CI-V command received. And the last one, if everything is correct, we return 4. Now let's test it in button. Integer error, let's create integer error code equal read VFO ERR. Inside is ICOM, radio ID, and VFO data working same. And now let's go through each error. If error code equals 0, before I wanted to create a label to show the error, but I decided to refuse from it and do it through the message box. So if error code equals 0, message box null, no serial port, second error, and mb underscore ok in the end, semicolon, return, semicolon. If error code is equal 1, message box null, radio not answering, next error, mb ok, semicolon, return. If error code is equal to message box null, wrong response from the radio, error mb ok, semicolon, return, semicolon. If error code equal 3, let it be no CI-V response. Error. MB OK. Semicolon. Return. And the last one, if error code equal 4, we just display our frequency. Label 5, caption, VFO data. Of course, we can write something on the message box that response received, but it's not necessary now. In any case, it's only example. Okay, we are not connecting port now, especially not connecting. Let's click read, so no serial port. Okay, let's connect it, but we'll not change baud rate. Read. Phone not radio not answering. It's uppercase radio. Other two I'm not able to test, so let's keep it like as it. Let's think it's working. In any case, we did error checking just for example. We're not going to use it now, maybe later, just to show you how it can be done for the errors, because in the timer we are not able to check the codes every time. We have to stop timer on any error received. Okay, let's put timer 1 enabled equal true in the button connect. When port is connected, timer start working immediately without button read, so we don't need it anymore. Let's spin the tuning knob. Everything is working. Now we need to make reading frequency processes to the background on the program. So we need to create a thread. We don't want frequency to be read in main thread, because if a lot of different timers and cycles working in the main thread, program will be working very slow. But we are going to add here reading a lot of parameters, plus we're going to add here sound. Both ways, from radio to computer and computer to radio, and we are going to add internet connection, so better to do everything on the background. To create an external to create a thread, we need a handle. Let's create handle read info, and let's name the thread is Dwartwin API read info. Just write it like as it. We don't need anything else. So inside the thread, we need to create infinite cycle while, so it will be working forever until you will not stop it. And inside this cycle, we create logic variable bool OK is equal read VFO ICOM radio ID VFO data. So now in this thread, frequency will be read on the background. But in the timer, we are not able to display the frequency on the label inside the Win API thread. So we need to use timer to display it. So let's leave in the timer only label 5 caption is VFO data. So every 50 milliseconds, if frequency is changed, timer will be display the new frequency. Let's create in the button connect. When port is connected, let's create this thread. Read info is equal create thread null 0 read info. It's the name of our thread. Null 0 null. Right now I will not going to explain what is it, what each parameter need. Just copy it like I wrote it, and it will be working. So let's start connect. So when we pressed connect, everything is working. We spin knob, everything is changing. Let's save everything, because if by any chance program will accidentally freeze or closed, you will lose all the data. And trust me, sometimes write the code again, it's not a very bad idea. Let's make one more optimization. Let's move read VFO functions into the separate C++ file. So we don't need it inside the main program, because it takes a lot of space. If we will put all the frequency in one program, it's a lot. Let's create two files. File other C++ file and file other H file. I already created these files before to be sure everything is correct and working, to not spend time on editing. So let's just copy it and paste into the H file. Inside the H file only the names of the functions we are using. Each function here should be finished by semicolon. So when we create a CPP file, on the top we should include our H file. So let's name it ICOM read info. Let's save it as ICOM read info.h. In this file we're going to add more functions like reading volume, reading S meter, reading power, reading most parameters. And let's name C++ file as ICOM read info. Now we need to include this file into our main program. So on the top, let's delete these functions from the main file first, because in other case on compiling we will get error. So on the top, let's include our file into the project. We need to include only H file. Include read ICOM read info, ICOM radio info.h, and we need to add into the project add to project. We need to add our created ICOM radio CPP file. So files included, everything looks working. Connect VF4 read, we can spin it. So now we moved read VF4 function into separate file, so we can use now it in any program. So we can create new project, and when we need to read frequency, we can use this CPP file for any program we have. So we don't need read frequency anymore, but let's keep it because it have error check. Probably we will need it in future. Let's save everything. For today we already finished. Next video I will show you how to write the frequency. So we will write function to read frequency, and we will to write frequency, so we can change it. And we will add some functions to read S meter, S meter, volume, and some other parameters. And so in the H file is in header should be the following files included. Okay, that's all for today. In 2-3 days I will upload new video for writing frequency, and after that we will try to work with STM32 board to make external VFO knob to connect to USB, because changing frequency by keypads is keys is it's not very useful. Better to have additional VF4 tuning.